When the big one hits, you expect highways, bridges, and buildings to be the first casualties. But what about pipelines? Consider the complete lack of water during the state of emergency following a major seismic event. That was the fear of the East Bay Municipal Utility District relative to the Claremont Water Tunnel, which was originally constructed in the late 20s and now serves more than 800,000 residents. The enemy? The Hayward Fault, a seismically active zone that threatened to sever the tunnel entirely in the event of a major catastrophe. The EBMUD assigned this challenge to the firm of Jacobs Associates, who, with the assistance of their subcontractors and academic professionals, came up with the innovative solution to retrofit the existing tunnel and perform bypass surgery by building another tunnel to reroute water through the fault zone. Their design needed to be unique since the team was looking to accommodate a large fault offset, 8.5 feet to be precise, should the Hayward Fault relocate. So, for the water to continue its course, the bypass tunnel expanded into a 17-foot wide vault that extended into both primary and secondary fault zones. Moreover, to reinforce this sizable vault in the event of cracks and breaks forming in the lining, enter two large side drifts completely overlapping the structural elements of the vault. To implement the principle of better safe than sorry, the team designed a carrier pipe, basically a pipe within a pipe, to carry water even if the bypass tunnel was blocked. For the solution with the fastest delivery time, the most reliable water transportation through a seismically active zone, and the most innovative design, the American Society of Civil Engineers is honored to present the Claremont Tunnel Seismic Upgrade Project with the Charles Pankow Award for Innovation. One wouldn't normally consider the importance of public works maintenance or facilities engineering when envisioning awe-inspiring armadas or stealthy submarines. However, significant infrastructure lies at the heart of an efficient, battle-ready fleet. Be it the Atlantic or the Pacific, Vice Admiral Michael Luce, professional engineer, member of the American Society of Civil Engineers, and Deputy Chief of Naval Operations for Fleet Readiness and Logistics with the U.S. Navy, has taken care of the Navy's facilities faithfully and honorably while steadily moving up the ranks, including a stint as commander of the Naval Facilities Engineering Command, or NAVFAC. Having received his commission as a humble ensign in the Civil Engineer Corps in 1975, his more than 3 decades as an engineer serving the nation's fleet have seen him master the art of acquisition and the science of logistics and operations. The Navy makes considerable investments in construction, the bulk of which involves the regular maintenance and upkeep of shore facilities. Enter Vice Admiral Luce playing the role of astute investment advisor to the Navy. In leading its shore investment strategy, he has helped ensure installations and facilities are properly sized, configured, sustained, and aligned to the Navy's strategic plan. What's more, through a series of judicious mergers between public works centers and engineering field divisions, he transformed NAVFAC into a single, aligned, and a much more efficient organization. The Regional Facilities Engineering Command, the infrastructure equivalent of a NORAD or a CENTCOM. This exemplary service to the nation has not gone unnoticed, as Vice Admiral Luce is a highly decorated officer, having received the Distinguished Service Medal, 5 Legion of Merit Awards, 2 Meritorious Service Medals, 2 Navy Commendation Medals, and 2 Navy Achievement Medals. For his demonstrated leadership, for his bold advocacy of research and innovation as a means to improve productivity, performance, and quality in the design, construction, and maintenance of U.S. naval facilities, and for his dedicated service to our nation, the American Society of Civil Engineers is honored to present Vice Admiral Michael K. Luce with the Henry L. Michel Award for Industry Advancement of Research. The Oregon Department of Transportation's Elk Creek Hardscrabble Creek Bridge Delivery Program threw convention out the window in employing the rapid replacement technique on the two bridges separated by the Elk Creek Tunnel on Oregon's Route 38. ODOT, as part of its $1.3 billion project to repair or replace Oregon's 365 bridges, began with a philosophy of no shortcuts allowed in the replacement of the Elk Creek Tunnel bridges. Since the bridges were so close to the tunnel entrance, there was no space to build the usual detour structures. What's more, reducing the existing two-lane highway to one would have erased a minimum of 20 minutes daily from the lives of nearby Elkton residents for over 6 months, not to mention all those traveling to the Oregon coast. Enter T.Y. Lin International, Slayton Construction, and their rapid replacement technique, tag teaming with Mammoth, a pioneer in the development and use of hydraulic skidding systems. Their solution: build the new bridge structures adjacent to the old one, build supports for the new bridge under the existing one, and finally slide the old one out of the way while the new one took its place. It was this final step that was executed like a scene from a blockbuster movie, replete with cranes and gigantic hydraulic jacks. In a feat that took just shy of 3 days for each of the bridges, the 47-person crew dismantled the old bridge spans while the new spans were moved down steel tracks to their final destination. Most of the time was actually spent in aligning the new bridges to the support structures with the stringency demanded by ODOT's seismic activity standards. For the efficiency, cost-effectiveness, and innovation in the ODOT's Elk Creek Hardscrabble Bridge Delivery Program, the American Society of Civil Engineers is proud to recognize it as an OCEA Award of Merit contender. Water has many merits, but in the construction industry, water is often the bane of their existence. John F. Donahue, member of the American Society of Civil Engineers, has managed to rein in many of these adverse effects, thus facilitating some of the most challenging construction projects. Joining the team of Moretrench American Corporation in 1964, Mr. Donahue quickly made a name for himself through his geotechnical wizardry, designing and installing impressive groundwater control and dewatering systems that enable the construction of everything from locks, dams, and sewage treatment plants to hydroelectric generating stations and nuclear power stations. It was only fitting that in 2007, he was appointed as the company's chairman of the board. He also had overall responsibility for the design and construction of the largest ground freezing operation ever performed in the U.S. The Boston Central Artery Project, better known as the Big Dig, utilized a highly complex ground freezing design to ensure the continued operations of Amtrak rail services crucial to the Northeast, while massive concrete tunnel boxes were jacked into position immediately below the tracks. A momentous project close to Mr. Donahue's heart came following 9/11, when he assisted the recovery effort and rehabilitation of the World Trade Center. His guidance and his intimate knowledge of the foundations Moretrench had worked on in 1968 ensured safe working conditions for the crew on the somber site, while preserving the dignity of those who lost their lives. For his prolific and invaluable contributions to the construction industry, as well as the American public, it gives the American Society of Civil Engineers great pleasure to present Mr. John F. Donahue with a Lifetime Achievement Award in the field of construction. Waste not, want not. In this era of environmental deterioration and climate change, such words challenge any engineer and sometimes add a degree of inspiration. Orange County's Groundwater Replenishment System is an example of a project that results from that inspiration. The GWR system, the largest water purification reuse project of its kind in the world, generates a new supply of water to meet the needs of 500,000 people. For a fairly arid region in California, this system is definitely a boon and ensures the county's groundwater basin doesn't go dry, to the tune of 70 million gallons per day. Wastewater effluent, often a resource dumped into the ocean, represents the sort of wastefulness that Orange County simply cannot afford, given the increase in local demands for water added to the diminished supply of water imported from outside. Rather than being focused on quantity, the GWR system is more concerned about quality. The water that is recharged into the basin is of such high quality that some impurity in the form of minerals is actually added. It all begins with a low-pressure microfiltration process, preparing the water for the reverse osmosis step. Not satisfied with this, the system then utilizes ultraviolet light and hydrogen peroxide to treat the already super pure water. Oh, and the whole system is also extremely energy conscious. With structures that have been designed to accommodate solar power, the GWR system uses variable frequency drives for added efficiency, cast in-place drill concrete piles to reduce vibration and sound, and reduces saltwater intrusion into the basin while lowering the output of wastewater into the ocean. For its socially and environmentally conscious design, invaluable contribution to the county's water supply, and the comprehensive nature of its water treatment, the American Society of Civil Engineers is proud to recognize the Orange County Groundwater Replenishment System as an OCEA Award of Merit contender. Protect America's strategic missile arsenal during the final phase of the Cold War. Protect the lifeblood of a community by safeguarding pipelines in seismically active zones. Protect commuters on the Brooklyn Bridge against a failing infill grid deck. If it sounds like something out of a superhero's resume, think again. It's all in a life's work for Jeremy Eisenberg, Ph.D., professional engineer, honorary member of the American Society of Civil Engineers, and a member of the National Academy of Engineering, whose brilliant and diverse career has taken him from defense applications to civilian ones and onward to excellence in design. As president and CEO of Weidlinger Associates Incorporated, he led the development and application of 3D nonlinear finite element methods to hardness assessment of silos for basing America's largest ballistic missiles. His contributions resulted in designing and testing the most survivable missile silos ever conceived. For Dr. Eisenberg, a conviction emerged from this experience and the counsel of his mentor, Dr. Melvin L. Barron, that design and computer simulation should advance in step with testing and field observations. And so he began a career-long involvement in large-scale experiments. When his design interest turned to the performance of pipelines during earthquakes, he developed data from post-earthquake field observations that led to a method for detecting vulnerable pipes prior to failure. He was also principal investigator for the joint NSF-NCEER-sponsored project to construct and maintain for 17 years instrumented pipeline segments across the San Andreas Fault near Parkfield, California. Subsequently, he led the conversion of computational methods from defense applications to civilian uses, which resulted in software products with applications to seismic oil prospecting, medical ultrasound imaging, and non-destructive evaluation. Dr. Eisenberg is now a senior principal at AECOM, where he advises on integrating advanced technology, especially computer simulation, with design of the firm's major infrastructure projects. His horizons at AECOM cover design challenges from tunnel ventilation to seismic base isolation to probabilistic risk assessment. The American Society of Civil Engineers, which recognized his past contributions with the Dennis Tewksbury and Ernest E. Howard Awards and the C. Martin Duke Award for Lifeline Earthquake Engineering, now presents Dr. Jeremy Eisenberg with a Lifetime Achievement Award in the field of design. The mission: to redefine the words expediency and efficiency in the annals of civil engineering. The goal? To rebuild a bridge that has gone down in infamy and tragedy. The challenges: time, safety, and the public eye. When Flatiron Manson was assigned the contract with the Minnesota Department of Transportation to rebuild the collapsed bridge carrying I-35 across the Mississippi River in Minneapolis, they were reminded of the importance the bridge had on the local economy and the trucking industry, and they were given a short 15 months to complete the project. Fig Bridge Engineering Incorporated created a design to stand the test of time. The record speaks for itself. At its height, 600 workers toiled around the clock 7 days a week. By scheduling multiple operations simultaneously, maximizing the size of the labor force, utilizing multiple sets of equipment, and working 24/7, the work was completed in 11 months, came in under budget, all while paying plenty of attention to safety and quality. Everything was done in volumes instead of ones and twos. Instead of constructing one pier at a time, all substructure elements were constructed together. Instead of setting up 1 or 2 casting beds on site to produce precast segments, 8 were used. Furthermore, the crew was given ample time to complete tasks while allowing for quality control and adherence to safety protocols. The way to do all this was just to hire more crew, and in the spirit of helping the local economy hurt by the demise of the old bridge, all crew and materials were locally acquired. And state-of-the-art systems were installed to monitor the bridge over the span of its service life. For its service to the local infrastructure and economy, as well as its innovation, quality, and timeliness in completing the mandated task, the American Society of Civil Engineers is proud to recognize the I-35 Bridge Project as an OCEA Award of Merit contender. Dams, dikes, levees, flood walls. What do all of these have in common? Well, for one, there's a small army of geotechnical engineers out there studying, analyzing, attending to, and improving upon these structures, and doing so at the highest caliber. Thanks in no small part to J. Michael Duncan, Ph.D., professional engineer, distinguished member of ASCE, and member of the National Academy of Engineering. Dr. Duncan is regarded as one of the foremost experts in the field of geotechnical engineering, while also being one of the best teachers in disseminating that expertise. As one of the rare individuals whose life work is reflected in quantity as well as quality, Dr. Duncan's contributions and achievements are simply too voluminous to list. He supervised 42 PhD dissertations, conducted 20 research investigations, been honored with more than 40 awards and lectureships, published 250 papers, 8 books and book chapters, 33 manuals and computer programs, and authored 98 research reports. There are few noteworthy geotechnical projects that haven't had the benefit of his expertise, as Dr. Duncan has consulted on over 60 projects around the world. Of particular significance has been his co-leadership of the Interagency Performance Evaluation Task Force, analyzing the flood wall and levees following Hurricane Katrina and determining how to prevent such failures in the future. Dr. Duncan is first and foremost an educator, given nearly half of his PhD students are themselves members of university faculty. His mission of teaching engineering students in a committed and inspiring manner began at the University of California, Berkeley, representing the first half of his distinguished career. The latter half saw him at Virginia Tech, where he was appointed the W. Thomas Rice Professor of Civil Engineering, and not long after as University Distinguished Professor, and more recently retiring as University Distinguished Professor Emeritus. For his 40-plus years of service as an exemplary mentor and teacher and his seminal contributions to his profession, the American Society of Civil Engineers is honored to present Dr. J. Michael Duncan with a Lifetime Achievement Award in the field of education. If you build it, they will come. And if you build it well, they will stay. That certainly describes the Lake Brazos Dam in Waco, Texas. Built in 1970, the dam was supposed to create a vigorous downtown core centered on the lake and waterfront. However, the failure of the dam to maintain reliable water levels and concerns about the structure's safety led to a return to the drawing board. Thankfully, it was the firm of Fries and Nichols and the U.S. Army Corps of Engineers who were entrusted with the task. While an innovative labyrinth weir was proposed to replace the faulty gate systems, which had been extensively modified in the mid-'80s, the costs were still too exorbitant and the environmental impact too unfavorable to greenlight the project. Not satisfied with the proposed methodology, Fries and Nichols did away with the costly need to divert the river, empty the lake, and build an entirely new structure downriver from the existing dam. In having the original project estimates, the design team used the gated spillway as the foundation for the labyrinth weir, thereby respecting the environment. They adopted a multi-phase construction plan, where one half of the dam was built while the other continued on without disruption, and so maintained river flow and lake levels. Having done extensive modeling and testing at the Utah Water Research Laboratories, the team also overcame several of the hydrologic and hydraulic challenges, ensuring in part that tailwater levels influencing the hydraulic efficiency of the weir, as well as the weir's own impact on upstream levels, were paid heed to. Finally, a structure emerged that for the first time yielded reliable lake levels and stood within the footprint of the original spillway. For its valuable contribution to the local infrastructure, its innovation and cost-effectiveness of design, and its sustainability, the American Society of Civil Engineers is proud to recognize the Lake Brazos Labyrinth Weir as an OCEA Award of Merit contender. Scale, scope, and complexity. Marry these words with rebuild, rehabilitate, and reconstruct, and a picture begins to take form, one that aptly describes